Hi everyone, I'm delighted that so many of you could make it today. The subject of my presentation is Scan to BIM for commercial buildings, infrastructure and heritage projects. By the end of this talk, you will be familiar with Scan to BIM workflow within different types of projects, illustrating how the process works and what benefits it can bring. I will start off by explaining the basic concepts and the workflow of Scan to BIM. After that, I will go on to benefits and the challenges of Scan to BIM adoption. Finally, I will show some examples of the use of Scan to BIM in actual projects. If you work in construction sector, you have probably heard the term Scan to BIM. But what Scan to BIM is, how does it work, what are benefits and the challenges of adopting Scan to BIM, and how it can be utilized in different project types. All of these topics will be addressed in this presentation. Scan to BIM is a process of creating an accurate digital representation of physical space by the use of laser scan technology and effective BIM process. How this works? A rotating emitter within the scanner case sends laser pulse. As the laser beam hits various objects, their position relative to the scanner is recorded as a piece of digital data. The large collection of these points is commonly referred as point cloud, and a sensor can capture panoramic 360 images while scanning to define the colors of each point. The point cloud is then imported into 3D modeling software to create accurate as-built models that can be used for designing progress monitoring, or even evaluating different design options. The workflow in a very simple way consists of the following stages: planning, laser scanning, data cleansing and registering, 3D modeling, and of course, the deliverables. Deliverables may include point cloud, panoramic 360 images, whether as part of the point cloud file or available on cloud or server, 2D plans, elevations, sections, quantity reports, assessment, asset information model, etc. In an actual project, we may need this workflow before and after construction works, or even during construction if needed. During the planning and design stages, Scan to BIM helps projects to improving the accuracy of site surveying. During construction stage, Scan to BIM can be used for coordination process, progress monitoring, site verification, as well as seamless handover at project closeout. An accurate as-built model for building can facilitate operation and maintenance activities, as well as renovation or building future additions to the asset. Benefits of Scan to BIM can be summarized as shown: high measurement accuracy up to millimeters that results in higher quality or higher output quality. Very fast measurement up to 2 million points per second. Subsequently, project time can be reduced. Having fewer errors when planning renovation or extensions for buildings. Since Scan to BIM can provide higher quality while reducing project time, increased profitability can be assured. What are the challenges of implementation of Scan to BIM? Laser scanners can be expensive, especially the accurate ones, along with computers cost and software subscriptions. Lack of expertise in the market is another challenge. Like any other technology, you first need to learn how to work with the hardware and software, so you have also training costs. And resistance to change is always a challenge while adopting a new technology. And of course, it exists here as well. To help you to get your head around, this section of the presentation will take you through Scan to BIM workflow within different types of projects, illustrating how the process works, what are the many challenges in each type of project, along with samples of our deliverables. Our first project is a commercial building in Riyadh, consists of 28 floors with approximate built-up area of 40,000 meters square. The scope of work includes architectural and interior fit-out, MEP works, laser scanning of actual as-built condition, coordination between IFC package and actual as-built condition, development of LOD 400 model, and shop drawing extraction. The main known challenge in this exact project was interface between new construction and actual site condition, while the biggest unknown challenge that occurred during execution was COVID-19 and the lockdown. Why scan to BIM was a must in this project specifically? This building was first designed and built as a hotel facility. Then it was decided to change the use into commercial office facility. Major discrepancies between project documents against the actual site condition were encountered. Scan to BIM was mandatory to record the actual site condition to be able to produce accurate shop drawings. The as-existing BIM model is compared with IFC regarding interface points and system continuity. Based on this study, and in case of any deviation, a building element can be either demolished or rebuilt or redesigned according to the existing condition. Thanks to cloud collaboration, specifically BIM 360 design and docs, the project team who were located in Jeddah, Dammam, and Cairo has continued working on the project, every team member from his or her home during the pandemic and the lockdown, maintaining almost same productivity rates. Revit and BIM 360 design were utilized for model creation. Navisworks was utilized for coordination review and issuing clash report. BIM 360 docs was used as a CDE. And this is a sample of our MEP shop drawing extracted from Revit in this project. Now we move to the next part, this section, which is infrastructure project. This time we won't be talking about specific, but multiple KCG projects. Scope of work usually include concrete repair, moisture insulation, MEP works, scan to BIM before and after repair works. Challenges in this kind of projects may include high humidity and high temperatures, large scale sites. You may also encounter accessibility issues. Concentrated MEP service can block the site of the scanner. Highly deteriorated areas can be a real challenge. Poor lighting can be an issue if panoramic 360 images are required. And BIM software limitations. BIM models are developed according to the point cloud and panoramic 360 images, along with information received from KCG site inspection team, using destructive, non-destructive test and GPR technology. Laser scanning of the existing condition can feed the model with the most crucial information before contractor even start work. Modeling can be automated. However, modeling and quantification of deteriorated areas is a bit challenging. And here are some samples of 2D documentation extracted from Revit. Using machine learning algorithms, Dynamo and Revit, we created a full model of walls from point cloud data in one of our projects. In other projects, third-party add-ins were also tested to automate piping creation. And in this kind of projects, I mean infrastructure project, automation was really useful for us. Now we move to the last part in our presentation, which is heritage. Again, we will talk about multiple heritage projects. The scope of work usually includes heritage impact assessment, structural assessment, recommendations for restoration, and scan to BIM for as existing condition. Challenges may include unavailability of as-built data in digital format, highly damaged areas, health and safety issues, large scale sites, high LOD requirements for modeling, BIM software limitations. BIM models are developed according to the point cloud and panoramic 360 images, along with information received from KCG site inspection team using non-destructive tests and GPR technology, in addition to data received from archaeological teams. The final output of scan-to-BIM is then shared with archaeological and inspection teams to include in their reports and output. Laser scanning of existing condition can feed the BIM model with the most crucial information before starting assessment and or restoration. And we have to scan, I have to mention that in heritage project, we have to scan in high resolution, which takes more time. Building components are analyzed and identified to determine the modeling method and the Revit categories that will be used to model the different building objects. Most BIM tools, including Revit, are targeted at designing new buildings. It is very difficult and very challenging to use Revit for existing structures, especially in heritage projects and heritage cases. This is a sample of 2D documentation of as existing condition extracted from Revit models. Integrating scan-to-BIM with structural condition assessment software of existing structures has added remarkable values to the outcome. Such integration is allowing the end users a higher level of control and asset management in a timely and cost-effective way. And thank you.